Okay, welcome back. In this particular episode, I will be explaining the nuclide. We all know that the nuclide, okay, let me use this. The nuclide is also the same thing as the nucleus. So for those of us who are already confused, what is a nuclide? Please, the nuclide is actually the same thing as the what? The nucleus, which has a defined proton and neutron number. Let me draw the nucleus of an atom again. This is the electron, which is negatively charged. This is the proton, it is positively charged. This is the neutron, it is neutral, has no charge. While both of them are found in the what? In the nucleus. My question is, if the proton is positive, electron is negative, neutron is neutral, the nucleus has what charge? Which is the combination of positive and neutral has what charge? So please, if you know the answer, please drop it in the comment section. The nucleus has what charge? So back to this. These are example of nuclide. Type of nuclide or type of nucleus. So we have the isotopic nuclide, we have the isobaric nuclide, we have isotonic nuclide, we have isodiapheric nuclide, and we have isomeric what? Nuclide. I repeat, the first one I have there is isotopic, isobaric, isotonic, isodiapheric, which is isodiaphers, and the last one is what? Isomeric. Okay, sorry about that. Like as I was saying, we have isotopic nuclide, isobaric, isotonic, isodiapheric, and the last one we have there is what? Isomeric. Now let me explain the first one, isotopic. Please take note. Iso simply means the same. The same. I believe most of us are already familiar with isotopic. Isotopic usually talking about the same proton number. The same proton number. So we can have something like hydrogen 1,1, hydrogen 2,1, hydrogen 3,1, whereby the number at the bottom is the proton number, while the number at the top is usually the what? The mass number. So they have the same what? Proton number. You also have uranium. Uranium is 92. We have 234, 235. This is 92 again. We have 236 uranium. We have 238. If I'm not mistaken, all of them they are 92, 92, 92. So this uranium you are seeing here now, all of them they have the same, all of them 92, 92, 92, 92. So they have the same proton number. So if you don't know whereby same elements having the same proton number but different mass number and the rest is called what? Isotope. So this nuclide is what? Is an isotopic nuclide. Then the next one we have there is isobaric. So whenever you hear the word isobaric, please take note. Isotopic is talking about proton. Isobaric is talking about mass number. So baric, mass number, or I can also call it the nucleus number. So this is how we call it, mass number or the nucleus number. Please, the proton and the neutron is called the what? The nucleus number. So now let me give you an example of that, which is the mass number. Let me give you an example of that. If you have argon is 40 and here is 18. Then calcium again, calcium is 40 and here is what? Is 20. So if you look at this closely, argon and calcium, they have the same mass number, but different proton number, different electron number, different this, different that. So this atom is called what? They are isobaric nuclide. So argon and calcium, these are isobaric what? Nuclide. So please take note of that. If you don't know whereby elements like this have the same mass number, they are called what? Isobaric nuclide. Then the next one we have here is isotonic. Isotonic. So isotonic is talking about the neutron. The neutron. Isotonic, I repeat, is talking about what? The neutron number. Let me give you an example. Okay, an example of isotonic nuclide is, let me say hydrogen 2,1, sorry, let me use 3,1, then helium is 4, and here is 2. So like what I said, an isotonic nuclide, they have the same what? Neutron number. So for you to get the neutron number, usually mass number minus atomic number. That is 3 minus 1 give us 2 neutron. 4 minus 2 give us what? 2 neutron. So they have the same neutron number. So if phenomena whereby element having the same or the nucleus having the same neutron number is called isotonic nuclide. So that's for that. Then the last one we have here, second to the last one, is isodiapheric. Isodiapheric or isodiaphers. Isodiapheric is talking about the same neutron number, but this very neutron number was gotten from nucleus number minus proton number for isotonic. Nucleus number from proton number, that's the number one we need. But for this isodiapheric, it's talking about the proton, then and the neutron. So when we have, which is n minus p. So if your n minus p is going to give us the same neutron number, therefore it is what? An isodiaphers. So when your neutron minus proton give us the same answer, which is, let me remove the neutron here. So if you have the same value, the same difference of neutron to proton, which is your neutron minus proton give us the same value, then we can now say they are what? Isodiaphers. For example, we have uranium 238, here is 92, and uranium 238, here is 92, and we have the thorium, yes, thorium 234, and here is what? 90. So the first that will come to your mind is that what is our proton? The formula is neutron minus proton for us to know if it is truly an isodiapher. So the question should be, what is our proton number here? Our proton number here is 90 for thorium, while for uranium our proton number here is 92. Then what about our neutron number? So for us to get our neutron number will be 234 minus 90. It gave us 144. So here I have 144. So let me put it here, 144 minus, why in this very one, 238 minus 92, you have 146. So here is 146. So if you subtract 92 from 146, you have 54. Why, if you do the same thing here, you are still going to have what? 54. So in this situation whereby they have the same difference between neutron to proton, I mean the same nuclear difference between the neutron to proton, we call it what? An isodiapher. Which is, if you subtract this from this and give us the same value for two different elements, it is called isodiapher. And assuming here was 144, that means they are isotonic. If they have the same neutron number, they are isotonic. If they have the same proton number, isotopic. If they have the same mass number or nucleus number, proton and neutron, it is called isobaric. If they have the same neutron number, it's called isotonic. And if the difference between the neutron and proton is the same, it is called isodiaphers. While for isomeric, it's talking about the binding energy. The binding energy that is occurring in this particular position. So for binding energy, it's isomeric. Isodiapher is talking about neutron to proton. Then isotonic is talking about the neutron. Isobaric is talking about the mass, while isotopic is talking about what? The proton. Now, let me give you a question. Then you tell me if it's isotopic, isobaric, isotonic, and isodiapher. We have carbon 12, we have carbon 13, we have carbon 14. So carbon 12, carbon 13, and carbon 14, please. Let me write carbon, carbon, carbon. We have 12, we have 13, and we have 14. So these carbons, are they option A? Are they isotopic? Are they isobaric? Are they isotonic? Are they isodiapheric, or they are isomeric? So please go through this whole video again and then answer this very question. Let me recap. Isotopic is talking about the same proton number. Isobaric, the same nucleus number or mass number. Isotonic, the same neutron number. Isodiapheric, the difference between the nuclide is the same. Then, I mean the nucleus, proton minus neutron is the same. Then, isomeric is talking about they have the same what? Binding energy. If you find this video useful or helpful, please Don't forget to smash the subscription button. Don't forget to drop the answer to this very question, because if you know the answer, if I see a lot of comments on my video, I realize that yes, indeed, students are actually following it. But if the reaction to the video is kind of low, I might stop the class. So please feel free to drop the answer to the very question. Share the video to your classmates. Send this video to your departmental group chat. See you in the next episode. For now, goodbye.